During a recent movie promotion, Fruity O's cereal placed mini action figures in some of its boxes. The advertisement on the box states 1 out of every 4 boxes contains an action figure. A group of promotional toy collectors suspects the proportion of boxes containing the action figure may be lower than 0.25. The group purchased 70 boxes of cereal and found 12 action figures. Assuming the 70 boxes represent a random sample of all the cereal boxes, is there evidence to support the toy collector's belief that the proportion of boxes containing the figure is less than 0.25? Provide statistical evidence to support your answer. All right, so we're going to use the 4C method to do this FRQ. So first we're going to choose our procedure. All right, so based on the question stem, there's only one sample. So this is going to be a one sample z-test for a proportion. Okay. Let's define our parameter. So P in this problem represents the true proportion of all boxes with an action figure. Okay. All right, our hypotheses. So the null hypothesis is that our parameter is equal to the null value, which is 0.25. The alternative hypothesis aligns with the suspicion, which is that P is less than 0.25. All right, our significance level. It does not tell us what significance level to use, so I'm just going to use the standard 5%. And then now our statistic. So 12 out of the 70 boxes in the sample had an action figure, and that is 0.171. Okay. It's actually, there's more digits, but I rounded it there. All right, so right now we have some evidence for the alternative because 0.171 is, technically speaking, less than 25%. Okay? But we don't yet know whether it is statistically significant or not. So we proceed to the next step. All right, we're going to check our conditions. So, random sample. Okay, if we go back to the question stem, right, it says right here that we can treat it as a random sample. So I'm just going to check that off. Next, the 10% rule, right? Is our sample of 70 cereal boxes less than 10% of all cereal boxes of this brand? And it's safe to say that that statement is true. Okay. Finally, the large counts condition. So n times p would be 70 times 0.25, and n times 1 minus p is 70 times 0.75. All right, so hopefully both of those products come out to at least 10. Okay, so 17.5 for that one, and 52.5 for that. All right, so we meet the large counts rule. Okay. All right, just a reminder, we check the random sample condition so that we can generalize to the population. The reason for checking the 10% rule is so that sampling without replacement is okay, and the reason we check the large counts rule is so that our sampling distribution is approximately normal, and then we can do normal calculations. All right, speaking of calculations, that's the next step. Okay, so we begin with the general formula. We're going to be calculating a standardized test statistic, which is defined as a statistic minus a parameter divided by an SD. All right, the specific formula for this procedure is to use p hat as the statistic, p as the parameter, and then the square root of p 1 minus p over n as the SD. All right, so our statistic was approximately 0.171. The parameter was 0.25, and then our SD will be 0.25 times 0.75 all over 70 in a square root, of course. All right, and then I'm going to calculate this off screen. So 0.171 minus 0.25 divided by square root 0.25 times 0.75 over 70. All right, so we get a standardized test statistic, aka a z-score, of negative 1.53. Yeah. All right, now we would like to know the probability of getting a test statistic or an outcome as extreme or more extreme as this. So we're going to use a standardized normal distribution since our test statistic is standardized. Okay, negative 1.53 is going to be in the left tail. Our alternative hypothesis is looking for evidence of a lower proportion, and so we're going to be shading the left tail. All right, now you're not going to see me do this, but off screen I'm just going to use normal CDF to get that tail area. So second vars normal CDF. All right, lower bound will be negative 99999. Upper bound will be negative 1.53. Mean 0, SD1. And the p-value is about 0.063. Okay. All right, now remember our significance level was 5%, and our p-value is greater than that. Okay. So in other words, the result that these toy collectors got is not statistically significant. And so they're not going to reject the null hypothesis. They have not found convincing evidence for the alternative. Okay. We're just going to write all that in context now. All right, so since the p-value 0.063 is greater than our significance level of 0.05, we fail to reject the null hypothesis. Okay. We do not have convincing evidence that, all right, I'm going to pause here because I'm just going to use the language in the question stem. All right, so the question was, is there evidence to support the toy collector's belief that the proportion of boxes containing the figure is less than 25%? Okay, so we do not have convincing evidence that the proportion of boxes containing the figure is less than 0.25. The proportion of boxes containing the figure is less than 0.25. All right, so that concludes our solution.